4.2 Soil Formation and Erosion Note. Soil, which is a mix of geologic and organic components, living organisms. And there is sand, silt, and clay, which are in the soil formation. And then humus, which is a main organic part of soil. And soil carries the nutrients of ammonium, phosphates, nitrates, and water and air. And then plant, which the anchor roots of plants provide water, shelter, and nutrients, which are nitrogen, phosphorus, potassium, and magnesium for plant growth. And here's a drawing of a plant. And then water, which filters with rainwater and runoff by trapping pollutants in pore spaces with plant roots. Clean water enters groundwater and aquifers. And then nutrient recycling, which is home to decomposers, break down dead organic matter and returns nutrients to soil, which is mostly where like decomposer, which is, for example, a worm. And then the habitat provides habitat for organisms like fungi, bacteria, mold, and slugs. And then weathering, which is a breakdown of rock in smaller pieces. And there's 3 types, which is physical, which is wind, rain, freezing. And then there's biological, which is roots of trees cracking down rocks. And then chemical, which is acid rain and acid from moss and lichen. And then weathering of rocks leads to soil formation. And then it's broken into smaller pieces and it carries away and deposited by erosion. And erosion is just the transportation of weathered rock fragments by wind and rain, carried to a new location and deposited. And then soil formation from below is weathering of parent material produces smaller and smaller fragments that make up geological inorganic part of soil, minerals, sand, silt, and clay. And then from above the soil, break down organic matter, adds humus to soil, and erosion deposits soil particles. And the effects of this is the effects of parent material is soil pH, nutrient content, and then the topography, which is steep slopes, is too much erosion, and then more level is better for the soil. And then climate, which is warm. When it's warm, it's faster to break down. And when it's colder, it's more weathering erosion since it's hard for the soil to break it down. And then there's 4 types of soil horizons, and here's a little picture that shows it. And then here it's the O, which is the layer of organic matter on top soil, and it provides nutrients and limits H2O loss to evaporation. And then there's A, the topsoil, layer of humus and minerals from parent material. And then here is where there's the most biological activity, which breaks down the organic matter to release nutrients. And then there's B, which is a subsoil, lighter layer below topsoil, mostly of minerals with little to no organic matter, and it contains some nutrients. And then C, which is the least weathered soil, that is closest to the parent material, called bedrock. And then here's another image which shows how water is able to enter more when it's a little bit like when it's sand, and then when it's clay, since sand is a little bit lighter than clay. And then there's Loss of topsoil, which is due mostly to tilling, and it disturbs soil, makes it easier to erode by wind and rain, and it removes the nutrients from the soil. And then compression of soil by machines, and it reduces the ability to hold moisture. For example, tractors and bulldozers are this example of compaction. And dry soil erodes more easily, and then it equals to less plant growth and less root structure. And then soil degradation is the loss of ability of soil to support plant growth. And then there's nutrient depletion, which growing crops on same soil removes key nutrients like nitrogen, phosphorus, potassium, and magnesium, and reduces the ability to grow future crops in that same space. And then there's the FRQ, which is design an investigation to measure the effect climate has on soil formation, and identify independent variable and dependent variable in experiment. And then what I put was an investigation to measure the effect climate has on soil formation, putting soil into two different containers and put one container outside for it to get sunlight and the other inside with no sunlight. The dependent variable is the amount of sunlight it gets, and the independent is the containers where soil is put in. And those are my notes for 4.2.